Now this question is looking at your understanding of polar and non-polar as well as melting point, and when we consider that, obviously we're considering the groups that are attached. So if we just look at melting point to start with, we look at cyclohexane. Obviously that's a ring structure and it's only got carbons and hydrogen, so we'd expect this to be a non-polar molecule, and the only way that this one could bond would be through induced or rather temporary dipole bonding or instantaneous dipoles, or dispersion forces. It's known by a number of ways, and the bigger the electron cloud, the bigger the molar mass. In other words, the stronger the bond. So this is the weakest form of bonding, and it's not that strong, hence we have a relatively low melting point. Now the other structures, cyclohexanol and the diol, do have higher molar masses, so we would expect with them just being bigger that they would actually have a higher melting point. But these are significantly different. They're much bigger than we would expect just based on it being a larger molecule with a larger electron cloud associated with it. Now cyclohexanol obviously is an OH, and that means it has the ability to hydrogen bond, and that's hydrogen bonding between cyclohexanol molecules. And so when those bonds get broken, we're melting that from solid to liquid, and the amount of energy to do that is much more than it would be for cyclohexane. And so that's hydrogen bonding, and we would comment on that being a stronger bond, and therefore it's going to take more energy. Now we could also mention the fact that this is a polar molecule, and then we move on to the 1,2 diol, and obviously we've got 2H groups here, which means it's got more capacity to hydrogen bond with other molecules, and that means that it's going to have a much stronger attraction between itself and other diol molecules, and hence we're going to have a much higher melting point. So we can talk about that with the forces of attraction between these and how it's reflected in the melting point increasing. Obviously the boiling point would increase as well. Now in terms of solubility, because this is non-polar, there's going to be no attraction between the cyclohexane and the polar water molecules. Therefore it's going to be insoluble. Now the presence of an OH group here means for cyclohexanol that it's going to have a ability to hydrogen bond with water. Now the fact that we're told that it's only sparingly soluble means it mustn't be that attracted to the water molecules, or the water molecules will not be that attracted to that. And so obviously the water molecules, in order are more attracted to each other than they are attracted to the cyclohexanol, so it only dissolves slightly. Now when we add another OH group on here, we get a greater ability for the diol to hydrogen bond with water. So for this one it becomes very soluble. So if we discuss all those factors in turn, we should be able to get a reasonable mark for this question. Okay. Now I'm going to attach the mark schedule answer to this because it's a pretty good evaluation of the question. And this is the mark schedule for that exam showing the answer. I'll just move that over. Okay, and that's available to print out.